Hello, my name is Sean Conway, and I'm a graduate student in cognitive psychology at the University of Massachusetts Amherst. This is a pre-recorded presentation for the 2023 virtual meeting of the Society for Mathematical Psychology. The title of my talk is Category Biases Arise from Learning Sets, but not from Choice Sets. This is work I conducted along with my advisor, Andrew Cohen. Categorization is a well-studied area of cognitive psychology. In a typical categorization experiment, participants must decide to classify a stimulus into class A or B. Participants are typically trained on category members known as exemplars. A prominent model of categorization, the Generalized Context Model, or GCM, proposes that people classify novel stimuli by comparing the stimulus to all previously seen exemplars stored in memory. The model states that the probability the participant classifies a novel stimulus into category A is equal to the stimulus's summed similarity to category A exemplars divided by its similarity to all exemplars from the experiment. Due to time constraints, I won't get into the similarity calculation. However, we might imagine that we could add a third category, dA, which acts as a decoy for the A category, in that it is more similar to A than B. The equation is similar, we just add one more term to the denominator. In its form here, the model satisfies independence of irrelevant alternatives, or IIA, in which the relative probability of selecting A over B is independent of the presence of the category dA. However, we know from decision-making research that decoy effects, where a decoy option biases people towards a target option, can violate this principle. Yearsley et al. Even showed similar effects in perceptual similarity judgments. To test this principle of the model, we designed a simple experiment where participants classified simple stimuli, a square with a line on its inner right side, into one of a few categories. The x-axis of this figure shows the position of the line. However, we varied the categories on which participants were trained between subjects. Some learned categories A and B, some learned A, B, and DA, and some learned A, B, and DB. Here, DA is a decoy category for A, and DB is a decoy for B. Critically, after learning, participants then classified an ambiguous, previously unlearned stimulus, equally similar to both A and B. The stimulus here is marked with an asterisk between A and B. We found that participants who were trained on categories A, B, and DA were more likely to classify the critical ambiguous stimulus into category A, while those who were trained on A, B, and DB were more likely to classify the critical ambiguous stimulus into category B. This decoy effect violates IIA and coincides with many similar findings in the decision-making literature. Next, we fit the GCM to the aggregate choice data for each condition. While the model captured some qualitative trends, it is unable to predict the change in relative preference for A over B based on condition. However, the GCM sometimes incorporates category bias parameters, which allow for bias to respond with a particular category label. We incorporated a version of the GCM where these biases are allowed to vary across condition and fit it to the aggregate choice data. The model does a great job accounting for the data and nearly perfectly accounts for the decoy effect. Looking at the fitted bias parameters, we can see that the biases for A and B change based on the categories that participants learned. This is a violation of independence of irrelevant alternatives. We also ran another experiment where participants learned all four categories, A, B, DA, and DB. However, they selected between various sets of options at test, A and B, A, B, and DA, and A, B, and DB. Notably, we do not see any decoy effects here. People are equally likely to classify the critical ambiguous stimulus as belonging to A or B, regardless of the choice set they picked from. To summarize, we observed a decoy effect based on the categories participants learned, but not those that they selected from. The GCM requires category bias parameters that vary across conditions to account for this finding, a violation of independence of irrelevant alternatives. Thank you for listening.